our revision part 3. Today we learn about, we will do some problems on momentum, principle, conservation of momentum, and force. So let's go through the first question here. Okay, define momentum. So in order to define physics concept or physics terms, if the terms has a formula like this one, like momentum has a formula P equal to mv, then we can just explain it based on the formula. But we need to be use the correct terms here, the correct words, in order to make it more sense. So we can say that momentum is the product. Product means multiplication. The product of mass and velocity of a moving object. So that is the definition of momentum based on the formula. M times V means that the product of M and V, the mass and the velocity of a moving object. So momentum only occurs if the object moves. So if the object is at rest, then we say that it doesn't have any momentum. The momentum is zero because the velocity is zero. Okay, number 2, a ball X with mass 5 kg moving with constant velocity. So we have mass 5 kg, velocity 20 ms negative 1. That is for ball X. Ball Y, mass 4 kg, moving with constant velocity 25 ms negative 1. Compare momentum of ball X and Y. So momentum of ball X, Px equal to mv. So m is 5 kg, v is 20, ms negative 1. So if we multiply both, we got 100 kg, ms negative 1. So that's for ball X. Now ball Y, same formula, 4 kg, 25 ms negative 1. So still has the same momentum. So we can say that both momentum are the same. Okay. So next, ball A moving with velocity 0.5 ms negative 1 meter per second. Ball B moving with velocity 3 meters per second in the opposite direction. So if it say in the opposite direction, then the velocity must be negative, and then the momentum also negative. Okay, so calculate momentum of ball A and ball B. So PA mv 2.5 kg times 0.5 meter per second. So we will get 2.5 times 0.5, 1.25 kilogram ms negative 1. So PB mv 1.0 kilogram. Velocity is 3 meters per second. So we will get negative. So don't forget that we have to put negative velocity here because of the opposite sign, the opposite direction. So we will have the negative value of momentum as well. Negative kilogram ms negative 1. Okay, done with question number 3. Let's see question number 4. From diagram below, calculate the total momentum of the car and lorry. So if it says total, that means addition. So we have to add. So we see that the both cars both car and lorries are moving in the same direction, thus have the same sign of momentum, so we can add it normally. So let's calculate the momentum of the car. So the momentum of the car, P car, equal to mv mass is 400 kilogram, V is 20 meter per second. So we will get 8,000 kilogram ms negative 1. So let's check 8,000. Yeah, 8,000. Okay, P lorry, same formula. 1,200 kilogram, 8 meter per second. We will get 9,600 kilogram ms negative 1. And then we can total at both momentum, we get 17,600 kilogram ms negative 1. Okay, so far so good. Number 5, given that the mass of lorry and car is 400 kilogram and 1,200 kilogram respectively, calculate total momentum of car and lorry. But this time, the car and lorry are opposite movement of each other, opposite direction. So that's mean we can define this lorry here to be negative direction because moving to the left. So P car MV, so our M is 400 kilogram, 40 ms negative 1, so we get 16,000 kilogram, 16,000 kilogram ms negative 1. So P lorry MV, M is 1,200 kilogram, V is negative 20 ms negative 1 because of the opposite direction. Got negative 24,000 kilogram ms negative 1. So the total minus 8,000 kilogram ms negative 1. So since the total has a negative sign, that means the lorry has a larger momentum overall. And if they both collide, then the car will be slightly to the left. Okay, the position of the car and the lorry will be on the left instead of on the right or on the middle. Okay, number 6. Given the total momentum of ball A and ball B is 2 kilogram meter per second, calculate V. So V is belong to the B. So we can define ball B to be negative direction, moving in the opposite direction. So total momentum MAVA plus MBVB equal to 2 kilogram meter per second. So we want VB equal to 2 divided by MAVA over MB. So 2 minus MA is 2.5, VA is 4, divided by B 1.0. So we will get VB negative 8.0 8.0 meter per second. So we get the answer also in the negative sign. So that means we done it correctly because ball B moving in the opposite direction. Okay, now let's move on to the principal conservation of momentum. So principal conservation of momentum state that total momentum conserved for collision S. When there is no external forces. Okay, so that's the principal conservation of momentum state. Okay. Ball A with velocity of 4 meters per second hits the ball B, which is in stationary. So when it's stationary, the momentum is 0. After the collision, the ball A stops. Okay, calculate the velocity of ball B. Before, okay. So MA, VP. Also, first we have to use UMV here because we have initial and final. So UA and UUV equal to MAVA plus MVV. So we want V after. So we want here the value of VB. So VB equal to MAVA plus MVVB minus MAVA divided by MB. So MA is 5, U is 4, 0, MBUB is 0 because stationary, minus MAVA. So MAVA also 0 because it stops. And then we can divide it by MB, 2 kilogram. So we will get the answer 20 divided by 2, 10 meters per second. Okay. So before we move on, there are two types of collision, elastic and inelastic. So basically, this type of movement here, since they're both not moving together or moving with common velocity, they're both separate. That means this is elastic collision. But if both balls here, after the collision, they move together, they move with a common velocity, they stick together, then it becomes inelastic. So there are one more type of situation where the principal conservation of momentum also true. In that case, we call it explosion. So explosion basically, we start at both objects at rest, and then suddenly both objects moving away from each other, opposite direction. Okay, we will see that later. So number 2, calculate the final velocity of the big fish. The big fish. So this is before and then this is after, like always. Let's write down the principal conservation of momentum. MB, VB. So we want the velocity, the final velocity. So we can say that we want VB. And VA and VB are the same here. So we can rewrite this before we rearrange, we can rewrite it as like this. MA plus MB V. V here because common velocity, and then we can rearrange. So V equal to MA UA plus MB UB divided by MA plus MB. So here, okay, why we have to add the masses after the collision? Because the fish now is inside this big fish. So that means the mass of the big fish increases. So we can add the masses. Okay. So MA is 2, UA at rest, so 0, plus MB 10, UB is 6. 2 plus 10. Okay, so 0 plus 60, 60 divided by 12, 5. 60 divided by 5 is 5 meters per second. Okay. We see that the velocity is slightly decreases because the mass increases. So it has larger inertia, so harder to change the direction and change the movement. Okay, so this is an example of inelastic collision because we have common velocity. The two objects stick together or move together. Okay, number 3 is an example of explosion because both the cannonball and the cannon are at rest first. They're both at rest, and then suddenly after the explosion, the cannonball moving forward, and the cannon also has a recoil backward, opposite direction. So both are moving away from each other. So this is an example of explosion, and the principle of conservation of momentum are still applied here. So given the mass of the cannonball is 1 kilogram and the fired from a cannon with mass 500 kilogram. If the cannonball moves with 250 meters per second, calculate the recoil velocity, which is the velocity of the cannon after the explosion. So let's write down the principal conservation of momentum. So basically, before the initial condition for both objects are at rest, so both doesn't have any momentum. So we can say it's 0. But soon as the explosion occurs, both have a momentum but opposite each other. So mass cannon, so we can MA, VA plus MB, VB. So we can make this is B, this is A. So we want MA, not MA, VA. We can rearrange it. Negative MVB divided by MA equal to VA. So VA equal to negative of MB 1 kilogram, VB 250, MA 500. So we get negative 250 divided by 500, negative 0.5 meter per second. And this answer is correct because we have the negative sign here as the cannon moving backward, opposite of the direction of the cannonball. So that's the first thing to check. And then the second thing is the magnitude of the cannon velocity, recoil velocity is smaller than the bullet because due to the bigger mass, has bigger inertia, so it's very hard to start to move. So the cannon is harder to move because of the big inertia. So it has a smaller velocity. So that is the second chapter. So let's see question number 4. A student with mass 5 kilograms stands on a boat. He jumps out from the boat to the jetty with a velocity 2 meters per second. The boat recoils to the backward as the student jumps. If the mass of the boat is 80 kilograms, calculate the velocity of the recoil. So this is an example of explosion. Okay, so basically we have a boat and then the students stand on the boat, and then after that the student jump from the boat, and then the boat moving backwards. So this is a completely an explosion problem. So this is before, this is after. So basically we can make it, this is object A and this object B. The initial momentum for both objects, the human, the student, and the boat are 0 because there is no movement at rest. So 0 equal to MA/VA plus MB/dV. Then we want to calculate the recoil velocity, which is the VA. So we can make negative MdV equal to divided by MA equal to VA. Okay, VA equal to negative MD. MD is 50. dV is 2. And then MA is 80. So we will get negative 100 divided by 80. Negative 1.25 meter per second. So again, correct because due to the negative sign moving in opposite direction, and also the magnitude is smaller than the student velocity due to big mass, big inertia. Harder to change movement. Okay, next. We learn about force and acceleration. So basically, this is the Newton's second law of motion that stated that force is directly proportional to the rate of change of momentum of an object and has the same direction as the acceleration. Okay, so what it means that F is equal to mv minus mu divided by p, and then we can factorize mass v minus u divided by p because both are the same, has the same mass. And then this part over here, v minus u over t, is actually acceleration. So the direction of the force is the same as the direction of acceleration. Okay, let's see the first question here. The box will move with acceleration, thus has a force. Okay, every time we see acceleration, constant or not constant, there is a force. External forces acted on the object. Calculate the acceleration of the box. Given the mass of the box is 25 kilograms. So let's see here, we have two forces. So we have to add up the forces. If both forces are in the same direction, then we can add up normally. But if it is in the opposite direction, then we have to subtract or make one of the forces negative, and then we can add up and see which the direction of the acceleration. So we call the process of adding up the forces, we call it as net forces, to find the net forces, the resultant force. So the net force. So we can say that F net or FR, R stands for resultant, equal to 5 Newton plus 15 Newton, because both forces shows towards the right. So right is the positive direction. 5 plus 15, 20 Newton. And then we can equal it to MA, the Newton's second law. We want to find A, F net divided by M. 20 Newton divided by the mass of the box is 25 kilogram. And then we got 20 divided by 25, 0.8. 0.8, the unit for acceleration is meter per second square. So we got correct there. And then the direction of this acceleration is actually the direction of the net force. Okay, number 2, if the block below accelerates with 1.2 meter per second square, calculate the frictional force acting to the block. So actually, we have only one force shown on the diagram, but if the box moves with acceleration, the box moves with an acceleration, then there exists frictional force. Okay, opposite to the movement. So we can say that F net equal to MA. So we calculate F net first. M is the mass, A is the acceleration, and then we get 2.5 Newton. So that is the net force. So in order to calculate the net force, we have negative F plus 4 Newton equal to 2.5 Newton. So F equal to 4 Newton minus 2.5 Newton. So 4 minus 2.5, 1.5. So the answer is correct. And the frictional force should be lower than the 4 Newton. We call it thrust. The thrust force should be, because it accelerates toward the thrust. So that means the thrust has a bigger force. Thus, the net force is actually in the direction of the thrust. Okay, number 3, the frictional force at 25 Newton acting on the block. Okay, F is 25. So if this is the thrust moving to the right, then the friction moving to the left. 25 Newton. Calculate the acceleration of the block. So first we need to find the F net. 45 Newton plus negative 25 Newton. So we will get 25 minus 25, 20 Newton. So the negative sign is due to the frictional is opposite direction in the left. And then we can make it to the Newton's second law. Rearrange because we want to find the acceleration. So 20 Newton divided by the mass 2 kilogram. 2 kilogram. We got 10 meter per second square. Okay, so our answer is correct. And the acceleration direction is actually the same as the thrust force. Okay, next, the frictional force increases to 45 Newton. What will happen to the motion of the block? Okay, since the frictional force is the same magnitude as the thrust force, so the net force is actually zero because 45 Newton plus minus 45 Newton, we got 0 Newton. So when we equate it with the Newton's second law, mass has a value. That means in order for this to become 0, the acceleration must be 0. So when the acceleration 0, what happened to the motion of the block is either moving with constant velocity, because constant velocity has acceleration 0. The initial and the final velocity is the same, thus the A is 0, or at rest. Also true because at rest velocity 0 and then acceleration automatic 0. So we have two situation here, and we cannot know which one the correct condition, but I expect it will be moving with constant velocity here. Okay. A block with mass 2 kg pulled with force 15 Newton and has frictional force 3 Newton. Calculate the acceleration of the block. Okay, so when we draw the diagram here, the block has mass 2 kg, 2 kg, and then pulled with force 15 Newton, frictional force 3 Newton. Okay, so what is the acceleration? The acceleration should be in this direction because this has a larger force. It contributes towards the net force. So first we calculate the net force, 15 Newton plus minus 3 Newton. And we got 15 minus 3, 12 Newton. Okay, so equate it into the Newton's second law, rearrange F net equal to M. Our F net is 12 Newton, mass is 2 kg. So 12 divided by 2 is 6 meter per second square. So same with the answer. And then the direction of the acceleration is the same as the thrust or net force. Okay, I think that's all for today. We learned that the momentum formula, the principle of conservation of momentum, elastic, inelastic, and explosion. Also, finally, we introduce Newton's second law. We practice with F equal to ma and how to find the net force, which force should be negative, which force that we can add up normally, and then we find acceleration using the Newton's second law. So that's all for me today. Hope to see you soon. Thank you.